Hello. Today we're going to learn about sum and difference formulas. Our essential question is, how do we use the sum and difference formulas to evaluate trigonometric functions? First, let's start off with our sum and difference formulas. The first one, sine of alpha plus beta, is equal to sine of alpha cosine of beta plus cosine of alpha sine of beta. Alpha and beta are going to be the two angles which add or subtract to give you the original angle. Our second formula, sine of alpha minus beta, is equal to sine of alpha cosine of beta minus cosine of alpha sine of beta. Notice that with the sine formulas, we intermix sine and cosine. We've got sine of alpha and cosine of beta together, and then on the other side of your addition or subtraction, you have cosine of alpha, sine of beta mixed together. But notice that we switch the alpha and the beta as we switch the cosine and sine. Second set of formulas, cosine of alpha plus beta is equal to cosine of alpha cosine of beta minus sine of alpha sine of beta. So notice on our cosine of alpha plus beta, when we're adding, over here in the formula, we are subtracting. Also notice that the cosines stay together and the sines stay together. For our second formula, cosine of alpha minus beta is equal to cosine of alpha cosine of beta plus sine of alpha sine of beta. Notice again, just like in the addition formula for cosine of alpha plus beta, notice on that one that we had the subtraction between our two sets of products. On the cosine of alpha minus beta, we have addition between our two sets of products. And once again, cosine stays with cosine and sine stays with sine. Go ahead and pause and copy these, and then we'll move on to some tangent formulas. Notice on our tangent formulas, we have two of them. Our tangent formulas, tangent of alpha plus beta is equal to tangent of alpha plus the tangent of beta divided by the quantity 1 minus tangent alpha tangent beta. And the second formula is similar to that. Tangent of alpha minus beta is equal to tangent of alpha minus tangent of beta divided by the quantity 1 plus tangent alpha tangent beta. Again, our signs in these formulas tend to follow the signs that we had in the sine formulas. When you have the addition formula for a tangent, notice we have addition in the top, and in the bottom we have subtraction. And then likewise on our subtraction formula for tangents, we have subtraction in the numerator and we have addition in the denominator. So as you go through, again, make a note of the things that stand out to you about these formulas, and that will help you to be more successful using them. Alright, go ahead and pause, and then we're going to move on and do 3 examples. First example, we want to determine the exact value of cosine of 75 degrees. Now, when we talk about finding the exact value, that means we need to use our unit circle to help us find the exact value of the cosine of 75 degrees. So the first thing I'm going to remember is that 75 degrees is in the first quadrant. So on my unit circle, 75 degrees is going to be located somewhere between 60 degrees and 90 degrees. So 75 degrees would be right here. What I want to do is I want to find an alpha and a beta that will either add up to equal 75 degrees, or I want them to subtract to give me 75 degrees. So you have this option: alpha plus beta equals 75, or alpha minus beta is equal to 75. So I want you to pause for a moment and see if you can figure out two angles that will either add to equal 75 degrees or two angles that will subtract to equal 75 degrees. And remember that they need to be angles that are on the unit circle. So we're looking for unit circle angles, the ones we memorized earlier in the year. So go ahead and pause, think about that, and then we'll come back and discuss it. Alright, so a couple of angles I come up with to add to equal 75. We could have alpha equals 45 degrees, and we could have beta equals 30 degrees. Those would add up to equal 75. Or we could have alpha equals, let's see, what could we have? 135 degrees, and beta equals 60 degrees, and if I subtract those, that would give me 75 degrees. So you decide which one works better for you, and then according to that, if you're using the 45 degrees and the 30 degrees, then we're going to use an addition formula for cosine. And if we're using 135 degrees and 60 degrees, we would use subtraction for the cosine of 75 degrees. So I'm going to use the addition ones just because it's a little bit more straightforward. It's the one that came to mind first. So because I'm using the addition ones, 45 plus 30 equals 75, that means I'm going to use the addition formula for cosine, which is cosine of alpha plus beta equals cosine of alpha cosine of beta minus sine of alpha sine of beta. Now this is where I need to remember my unit circle. So let's go back and look at our unit circle real quick. At 45 degrees, my cosine value is square root of 2 over 2, and my sine value is also square root of 2 over 2. So when I plug in for the cosine of alpha, alpha being 45 degrees, cosine of alpha is square root of 2 over 2, and sine of alpha is also square root of 2 over 2. So I'm directly plugging in this value for the cosine of alpha and the sine of alpha. Now I'm going to go find the cosine of beta. Well, beta is my 30 degrees. So if I think about my 30 degree angle, my ordered pair is square root of 3 over 2, comma 1/2. Remember, cosine is the first number, sine is the second number. So cosine of beta is square root of 3 over 2, and sine of beta is the 1/2. And so I plug those directly in for each one of these. Remember, we're finding an exact value. We're not putting it in the calculator and getting a decimal. These are exact values for this particular number. And then the last thing I'm going to do is I'm just going to simplify these products and make an expression out of it. So square root of 2 times the square root of 3 is the square root of 6. 2 times 2 on the denominator is 4. So I have square root of 6 over 4 minus, multiplying over here, square root of 2 times 1 is the square root of 2 over 2 times 2 is 4. This would be my exact value for the cosine of 75 degrees. You could also write it as the square root of 6 minus the square root of 2 over 4, and just make it into one fraction. But these would be the exact value of the cosine of 75 degrees. Go ahead and pause, and we will continue on with the second example. Before we move on to the second example, I just want to show you that the other two numbers that we had chosen, 135 and 60, would have also worked for this particular problem if we used the subtraction formula. From what you've written above, the subtraction formula for cosine of alpha minus beta is cosine of alpha cosine of beta plus sine of alpha sine of beta. And if we use our unit circle that we were working with earlier, 135 degrees is over here in the second quadrant. My ordered pair for 135 degrees is negative radical 2 over 2, comma, radical 2 over 2. And 60 degrees is still in the first quadrant, and that ordered pair is 1/2, comma, radical 3 over 2. So now if I plug those numbers in, remember the first one's my cosine, second one's my sine. So the cosine of alpha, negative radical 2 over 2, times the cosine of beta, 1/2, plus sine of alpha, radical 2 over 2, sine of beta, radical 3 over 2. When I simplify this, I get negative radical 2 over 4 plus radical 6 over 4. You will notice that this answer is the same as this answer over here. They're just switched. But notice that the radical is, or the negative is still on the radical 2, and the radical 6 is still positive, and they are both over 4 as before. So this is the same answer, it's just rearranged. So notice we get the same answer whether we use the sum formula, which is the alpha plus beta, or we use the difference formula, which was the alpha minus beta. So go ahead and finish copying this example, and I will pause and we'll move on to example 2. In the second example, we want to determine the exact value of the sine of pi over 12. So the first thing we do is we recognize that pi over 12 is in radians, and so on this one I'm going to be working with my unit circle in radians. Pi over 12 is equal to pi over 3 minus pi over 4. So my alpha is going to be pi over 3, my beta is going to be pi over 4, and we will be using the difference formula for sine. So we're going to be doing sine of pi over 3 minus pi over 4. And so we will be doing the sine of pi over 3 times the cosine of pi over 4 minus the cosine of pi over 3 times the sine of pi over 4. Now remember, pi over 3 is the same as 60 degrees, so our ordered pair is 1/2 radical 3 over 2. Pi over 4 is the same as our 45-degree angle. So our ordered pair is radical 2 over 2, radical 2 over 2. And so let's go ahead and plug these numbers in and see what we get. Sine of pi over 3 is the second value at 60 degrees, radical 3 over 2. Cosine of pi over 4, the first value, is radical 2 over 2 minus cosine of pi over 3, 1/2, times the sine of pi over 4, radical 2 over 2. And as we simplify, we get square root of 6 over 4 minus the square root of 2 over 4. And this would be the exact value of the sine of pi over 12. Now I want you to notice that we got the same exact answer as we did for the cosine of 75 degrees. What you're going to notice is you're going to see these same radicals showing up over and over and over again. Not always going to have the same signs on them, but you will always see square root of 6 and square root of 2 and a common denominator of 4 as you work through these problems. So don't be surprised when you see repetitions in your answers. Okay, go ahead and pause and we'll move on to the third and final example. Alright, for the third example, we want to determine the exact value of the sine of alpha plus beta, given that the sine of alpha is 4/5, where alpha is between 0 and pi over 2, and the cosine of beta is equal to negative 12 over 13, where beta is between pi over 2 and pi. Now, first thing we're going to notice is we need to figure out where this is on our circle. So if we're between 0 and pi over 2, that means we are in quadrant 1. So alpha is in quadrant 1, and beta is between pi over 2 and pi. That means beta is in quadrant 2. Now that's going to be important because when we make our triangle in our circle, it's going to help us to decide what our signs are. So if sine is in the first quadrant, or if alpha is in the first quadrant, remember that the sine is opposite over hypotenuse. So the 5 is my hypotenuse, and the 4 is the vertical side, or the opposite side. So what would this third side be? Well, hopefully you remember your Pythagorean triples, and the third side, the adjacent side, would be 3. So the sine of alpha was already given to us. That was 4/5. The cosine of alpha is going to be 3/5 because we do adjacent over hypotenuse. Now let's go to the beta. Beta is going to be over here in quadrant 2. You really don't need the circle because it's not a unit since our hypotenuse is 5 on the first one. But beta is, or cosine of beta is negative 12/13. So the hypotenuse is 13. Negative 12 is my adjacent side. So negative 12 is down here on the base, or the adjacent side. And if you remember your Pythagorean triples, the third side has to be 5. Now in the second quadrant, sine is positive. So the 5 has to be positive because it's going up. So again, we already know the cosine of beta is negative 12/13, and the sine of beta is going to be 5/13. So we do opposite over hypotenuse, and this was our adjacent. So again, the sine is 5/13. And now that I already know all of my values, I can go ahead and find the exact value of the sine of alpha plus beta using the formula. So sine of alpha plus beta is equal to sine of alpha cosine of beta. Remember, sine, in the sine formula, sine and cosine like to mix, plus cosine of alpha, sine of beta. Plugging in, sine of alpha is 4/5. Cosine of beta is negative 12/13. Plus cosine of alpha, 3/5. Sine of beta, 5/13. Now that I have all my numbers plugged in, we're going to multiply fractions straight across. So we've got negative 48 over 65 for the first fraction. Second fraction, we've got 15 over 65. And when we combine those together, negative 48 plus 15 is negative 33 over 65. And this is our exact value for the sine of alpha plus beta. So finish copying this example into your notes and have a good day.